Hello and welcome to my channel. Walter here, and today I'm going to be taking you through the October-November 2023 paper, that's 9709/13. But before we get into the paper, I have a special gift for you, which is a revision ebook which I'd want you to download from the link which is in the description. And I know you're going to find this to be of much help. So now let's get into the paper. Alright, so we're going on to question number 1. It says, a curve is such that its gradient at a point xy is given by dy by dx is equal to x minus 3x to the minus a half. It is given that the curve passes through the point 4, 1. Find the equation of the curve. Alright, so for this particular question here, we have been given dy by dx and they want us to find the equation of y. So we're going to say y is equal to the integral of x minus 3x to the minus of a half with respect to x. Alright, so this means that y will be equal to, and if we integrate x here, we are going to get x squared over 2, and if we integrate 3x to the minus a half, this will be 3x to the minus of a half plus 1, and that will be over minus a half plus 1, and it's plus c. So this will then give us y is equal to x squared over 2, and here that's going to be minus, and when we say minus a half plus 1, it gives us a half, and 3 divided by a half is 6, so we have minus 6 of x to the power of a half, which we get from minus a half plus 1, and it's plus c. So this is what we'll be getting. Now, we've been told that the curve passes through the point 4, 1, so since it passes through the point 4 and 1, we know that when x is 4, y is 1. So I'll have 1 being equal to 4 squared over 2 minus 6 of 4 to the half, and it's plus c. So that's 1 is equal to, and 4 squared over 2 is 8. And that's minus here, 4 to the half is 2, 6 times 2 is 12. So we have 12 here, and it's plus c. So we have 8 minus 12 here, which is minus 4, and if we take the minus 4 to the left side, it adds to 1, and that becomes 5. So we can see here that c is 5. So therefore, the equation of the curve should now come out as y is equal to x squared over 2 minus 6x to the half, and it's plus c. The c is 5, so it's going to be plus 5, and this is the answer we get. That's the answer they want us to find, which is the equation of the curve. So that's how we do it for question number 1. Let's move on. Alright, let's move on to question number 2. On number 2, the question is saying, the circle with the equation x minus 3 squared plus y minus 5 squared equals to 40 intersects the y-axis at points A and B. Alright, so on A they say find the y-coordinates of A and B, expressing your answers in terms of surds. Alright, let's answer that question. Alright, so here the key part is that at the points A and B, they told us that the circle intersects with the y-axis. So I'll say here at intersection with y-axis, with the y-axis, alright, we know that x is equal to 0. So we're going to put 0 for x into this. So that will become here 0 minus 3 squared. So it's just going to be minus 3 squared plus y minus 5 squared being equal to 40. Alright, so minus 3 squared is 9, so 9 plus, and expanding this bracket we get y squared minus 10y plus 25 being equal to 40. All right, so rearranging, we'll be having y squared minus 10y, then 9 plus 25 is 34, and if we take the 40 to the left, it will be 34 minus 40, which is minus 6, and that's all equal to 0. All right, so we need to solve this equation here. So I'm going to use the calculator, all right, for this, for a quick working. So I'll go to the quadratics mod, option 5 and option 3. Then the coefficient of y squared is 1, so 1 equals, then minus 10 equals, then minus 6 equals, and when we solve this we get one of the roots being 5 plus root 31. So we have therefore y coming out as 5 plus root 31, or the other value we get is 5 minus root 31, or 5 minus root 31. So these are the y coordinates. Let's move on to part B. On part B, the question says, find the equation of the circle with AB as its diameter. All right. Okay. Now, the 2 points, A and B, we know that for these 2 points, x is 0, and the y coordinates are these two here. So if AB is a diameter, it means that the midpoint of AB should pass through the center of the circle. All right. So we're saying here, if we want to find the center of the circle, of that circle that they're talking about, it has to be equal to the midpoint of the diameter, right? All right, so for this, we will be saying for the 2 points, the coordinates, x coordinates are 0, so it will just be 0 plus 0 over 2, which is just 0. For the y coordinates, that's 5 plus root 31, and it's plus 5 minus root 31 and over 2. All right, so this will give us the coordinates of the center of the circle. So here's 0, and 5 plus 5, that's 10. 10 over 2 is 5. Root 31 minus root 31 is 0. 0 over 2 is 0. So the center of the circle is 0, 5. Okay. Now for the radius, okay, so let's talk about the radius here. For the radius, since AB is the diameter and we have the coordinates of A and B, to get the radius, remember A and B are on the y-axis, all right, they're on the y-axis, on the vertical axis. So we can simply find the length of AB, or the radius, to be equal to half of the diameter is half of AB, which is half of AB. We are subtracting 5 plus root 31 minus 5 minus root 31. Okay, so that's half of 5 minus 5, that's 0, root 3 minus of negative root 31, which is 2 root 31. So we get that the radius is half of this, which is just root of 31. So this is very important. Okay, that's how we find the radius here. So to get the equation of the circle now, since we have the coordinates of the center and the radius, we can now simply say that the equation of the circle, let me just write that down, equation of circle is equal to x minus 0 squared, so that'll just be x squared, and is plus y minus 5 squared and is equal to the radius squared, which is root 31 squared, which is just 31. So this is the answer right here. That's the equation of the circle as required. So that's basically how we do it. I hope you've understood that. Let's move on to question number 3. On question 3, it says, on part A, show that the equation 5 cos theta minus sin theta tan theta plus 1 equal to 0 may be expressed in the form a cos squared theta plus b cos theta plus c equal to 0, where a, b, and c are constants to be found. Right, so let's answer this particular question here. So here we are going to have that as 5. Okay, so 5 cos of theta minus sine theta of, for tan theta, we're going to use the identity that tan theta is sine theta over cos of theta, and here that's plus 1 equal to 0. Okay, so this is what we have here. So basically we have 5 cos theta minus sine squared theta, and it's over cos of theta plus 1 equal to 0. Okay, so multiplying all the terms by cos theta, so each term by cos theta, so that we get rid of the fraction. So I'll do that for each term. We will get right here 5 cos squared theta, and here they cancel. We get minus sine squared theta, and is plus cos theta, and it's equal to 0. We're going to use the identity on sine squared theta so that it becomes 1 minus cos squared theta plus cos of theta equal to 0. Okay, so basically 5 cos squared theta minus cos squared theta will give us 6 cos squared theta, and I have the cos theta here already, and minus 1. All right, minus 1, and it's equal to 0. Okay, so we have thus answered the question as they want us to do. We have expressed it in the form they say we should express it in: a cos squared theta plus b cos theta plus c equal to 0. So that's how we do it on 3 part A. On B, they then say, hence solve the equation, which is the original equation. All right, so since we had already expressed the original equation in this form, we are going to make use of that form in place of the original form. So I'm going to take this and I'm going to use that instead. Okay, so here it is. Okay, so we're solving this, and apparently it's a quadratic expression that we have. So I'll say here, let u be equal to cos theta, such that therefore we'll be having 6u squared plus u minus 1 equal to 0. We can try to factorize this to see if we can get something out of it. Okay, so here I'll have 3u and 2u and 1 and 1, and this should be a plus and this should be a minus. So minus 2u plus this. I think we're good. So we're saying here it's either 3u minus 1, that's equal to 0, or 2u plus 1 equal to 0, where we get u here coming out as a third and u here coming out as minus a half. So basically what we are saying is that therefore cos theta is equal to a third. Let's try to solve this, all right, for theta. So we know that we can get the principal value as arc cos of a third. And for arc cos of a third, with our units in radians, on the we have shift cos of a third. And for this one here, we get in radians 1.231. Okay, so 1.231. So remember, since the range is in radians, our answers should be in radians, and 1.231 is within range. Okay, you can see that 2 pi is actually 6.283. So as long as we have a value between 0 and 6.283 and so on, then it's within the range. So this value is fine. And if you consider the quadrants, all right, we know that cos is positive in the first quadrant, where we got the value 1.231, but it is also positive in the fourth quadrant, where it'll be it'll be 2 pi minus theta, which is minus 1.231. So the other solution should be that 2 pi minus this. So I'll just say here, this is what we'd gotten. So I'll say 2 pi minus ans, and we get 5.05 right here. Our answer should be 23 SF, so I'll just have that as 1.23 here, and the other one we got that as 5.05. So these are two solutions, and I'm sure these are the only two solutions within range. Let's go on to having cos theta being equal to minus of a half. All right, so theta is equal to, and we do arc cos of minus a half. All right, and for this, we know that this will give us shift cos negative 0.5, and here we get 2/3 pi. So one of the values is 2/3 pi. All right, the first quadrant value, okay, let's just have the few quadrants. Let's do a quick one here. So if we consider the quadrants, we know that cos is negative in these two quadrants, right? So basically the 2/3 pi we got is in this quadrant here, and the fourth quadrant, the third quadrant value for this, which is also the next value that we want, should be pi plus theta. The theta is the first quadrant value, so let's just say shift cos of negative 0.5 is 1/3 pi. So pi plus 1/3 pi, because the first quadrant value, though it's not required, it's not our answer, is 1/3 pi. That's our theta. So pi plus this should give us 4 pi over 3. So we have 4 over 3 of pi. So these here are the solutions which are within range: 1.23, 5.05, 2/3 pi, and 4 over 3 of pi. So these are the 4 solutions required, and that's how we solve part B. Now we want to move on to the next question, which is number 4. So let's do that. Question number 4 is right here. All right, so on number 4, it says, on part A, expand the following in ascending powers of x up to and including the term in x squared. All right, and we have on part 1, 1 plus 2x raised to the power of 5. All right, 1 plus 2x raised to the power of 5. Right, so right here, we're going to use the binomial expansion. So it's going to be 1 plus 2x raised to the power of 5 is equal to 1 plus 5 of 2x plus 5 of 4 over 2 factorial of 2x squared, and it goes and so on, but they just want us to end at the term in x squared. So this is going to be 1 plus 5 times 2x, that's 10x, and here 5 times 4, that's 20. 20 divided by 2 factorial is 10. 10 times 2 squared is 40, so we have 40x squared here. So this is what we get on part 1. On part B, they also want us to expand 1 minus ax raised to the power 6. So this gives us 1 plus 6 of minus ax, and is plus 6 of 5 over 2 factorial of minus ax squared. Okay, so this is where we're going to end, because it's up to the term in x squared. So it's 1 minus 6ax, and here 6 times 5, that's 30. 30 divided by 2 factorial is 15. So basically we have plus 15 a squared x squared. So that's what we get right here. Okay, so that's how we do it for part A. Let's go on to part B, which says in the expansion of 1 plus 2x raised to the power 5 of 1 minus ax raised to the power 6, the coefficient of x squared is minus 5. Find the possible values of a. All right, so here what we're going to do is we are going to have the 1 plus, okay, we are going to say 1 plus 2x raised to the power 5. Let's just write the expansions so that we don't waste time. So the expansion for the first one is this, up to the term in x squared. All right, here it is. So that's the up to the term in x squared, that's 1 plus 2x to the power 5. Then up to the term in x squared for 1 minus ax to the 6, we got this. So this is what we have right here. Okay, all right, so to get a term in x squared, since we're multiplying the first bracket by the second bracket, it will happen when this 1 multiplies 15 a squared x squared, and when 10x multiplies minus 6ax, and when 40x squared multiplies 1 in the second bracket. So that's how we get the term in x squared. Okay, so I'll say here, therefore the term in x squared is 15 a squared, and here it's minus 60a, and it's plus 40 here, and it's all of x squared. All right, so this is what we have. That's the term in x squared right here. Now the question says that the coefficient of x squared is minus 5. So the coefficient is here. So we are therefore saying that 15 a squared minus 60a plus 40 should be equal to minus 5. And I'm going to take the minus 5 to the left. So it's 15 a squared minus 60a plus 45 is equal to 0. All right. Now, I'm going to factor out the 15, and we'll be having a squared minus 4a, and it's plus 3, and it's equal to 0. All right. And with this, I will have the 15, and we will say, if we factorize this, this is a, and this is a, 3, 1, minus and minus. All right, which therefore means that a has values 3, or a has a value of 1. So these are the possible values of a right here. A can be 3, or a can be 1. So this is how we do it for this particular question right here. All right. Let's move on, and we actually are moving on to the next question, which is question number 5. All right. Let's look at question number 5. It says, the first, second, and third terms of a geometric progression are 2p plus 6, 5p, and 8p plus 2 respectively. So in part A, find the possible values of the constant p. All right. So here we have the terms in a GP. First term, second term, third term, according to what they say. So we know that if we say 5p over 2p plus 6, that's second term divided by first term, we should get the same thing as 8p plus 2 divided by the second term, which is 5p. All right. So we're saying this divided by this is equal to this divided by this. Both results should give us the common ratio, basically, right? So cross multiplying, we'll be having 25p squared if we multiply this 2. All right. And if we multiply this 2, this is going to be equal to 8p plus 2 of 2p plus 6. All right. So that's going to be 25p squared is equal to, expanding the brackets, 16p squared plus 4p plus 48p plus 12. All right. And if we take everything that's on the right side to the left side, we will be having 25 minus 16p squared. That should be 9p squared. Then 4p plus 48 is actually 52. So here that's going to be minus 52p, and it's minus 12, and it's all equal to 0. All right. So we need to solve this particular quadratic equation. All right. We need to solve it. So how are we going to do it? We can try to factorize it if we can. We can try factorizing it. Let's do the factorization. So we can have two brackets here equal to 0, and I'll have 9p here and p. Factors of minus 12, we are going to have 2 and 6, then 2p, 9, so plus here and minus, and I think we should be good because 2p minus 54 is minus 52. I think we should be good. So p should have a value of, actually, we can say here it's either 9p plus 2 is equal to 0, or p minus 6 is equal to 0. So the possible values of p are going to be that p is equal to minus 2 over 9, or p is a value of 6. So these are the two possible values of p. All right. So that's how we do it right here. On part B, they say one of the values of p is found in A is a negative fraction. So they're talking about p being equal to minus 2 over 9. And they say use this value of p to find the sum to infinity of this progression. All right. So p is minus 2 over 9. What is A, the first term? A is 2p plus 6. So it's 2 of minus 2 over 9 plus 6. All right. Quickly. 2 of minus 2 over 9. Okay. Delete. Plus 6. And that's 50 over 9. So we have 50 over 9. That's our A. Then common ratio R is found, can be 5p over 2p plus 6, or we can use 8p plus 2 over 5p. Any one of the two we'll do, let's use the first one, 5p divided by 2p plus 6. That's r, 5p, which is 5 of minus 2 over 9. And that's over 2p plus 6, is it? 2p plus 6. 2 of minus 2 over 9 plus 6. Alright, so essentially r is 5 of minus 2 over 9, and that's divided by 50 over 9 is essentially, okay, and that gives us minus a fifth. So we have minus a fifth here. Right, so basically for sum to infinity, we find it by a over 1 minus r, which essentially will give us 50 over 9 divided by 1 minus of minus a fifth, which is 1 plus a fifth. So basically we have 50 over 9, and that's over, for 1 plus a fifth, that's like 6 over 5, right? So let's do the division, right? And we get 125 over 127. So 125 over 127 is the answer. That's the sum to infinity right here. And that's how we do it. All right, let's go on to the next question, number 6. It says a line has equation y is equal to 6x minus c, and a curve has equation y is equal to cx squared plus 2x minus 3, where c is a constant. The line is a tangent to the curve at the point P. Find the possible values of c and the corresponding coordinates of P. All right. Okay, so let's look at this question here. We're talking about the fact that the line is a tangent to the curve. So we can solve these two equations simultaneously. So I can equate the cx squared plus 2x minus 3 to 6x minus c. All right. And what we're going to do is we're going to take what's on the right side to the left side. So we'll be having cx squared plus 2x minus 6x is minus 4x. So I'll have minus 4x here, and it's plus, and here we'll be having minus 3, and the minus c becomes a plus c equal to 0. So we basically have this quadratic expression. All right, and since the line is a tangent, we know that b squared minus 4ac should be equal to 0. All right, so b squared minus 4ac is minus 4 squared minus 4 of c of minus 3 plus c equal to 0. So that's 16, and it's plus 12c, and it's minus 4c squared equal to 0, which can be rewritten 4c squared minus 12c, all right, plus 16 equal to 0. Like this. Actually, it's minus 16 because we're taking them to the other side. So it's minus 16 equal to 0. Okay, factoring out a 4, that's c squared minus 3c minus 4 equal to 0. So that's 4, and we try to factorize this, and c, and we have 4 and 1, so 4, 1, then minus and plus. So we factorized it so that either c minus 4 equal to 0 or c plus 1 equal to 0. So the possible values of c are 4, or c is minus 1. So these are the possible values of c as required in this question here. Okay, so now that we have the values of c, the question also says and corresponding coordinates of P, and corresponding coordinates of P. Okay, let's take the situation when c is 4. Okay, so when c equal to 4. We know that the equation here will be y is equal to 6x minus c. So it will be y equals to 6x minus 4. All right. That's the value of c right here. Okay. So for the coordinates of P, at P, that's where the curve and the line intersect. And when we combine them, we actually got this to be the quadratic equation we got from there. So essentially, we are saying that also when c is 4, we'll be having cx squared, which will now be 4x squared minus 4x plus minus 3 plus 4, which is plus 1, equal to 0. And you can see here that this is a perfect square. It actually is, in fact, 2x minus 1 squared. Okay, and solving for x here, we should get x coming out as a half. All right, and when x is a half, from this equation, when x is a half, y will be 6 of a half minus 4, which is 3 minus 4, which is minus 1. So basically, the coordinates here will be half is the x coordinate and minus 1 is the y coordinate. So half and minus 1, that's much better, isn't it? Okay, so we also need to look at a situation when c is equal to minus 1. So y will be 6x minus c. Okay, y is 6x minus c. So it's 6x minus of minus 1. So it'll be plus 1. And the equation will be, since it's minus 1, it'll be minus x squared. So let me write that down. Minus x squared plus 4, minus 4x. And it says minus 3 plus c here. It's minus 3 minus 1. So that will be minus 4. Like this, and it's equal to 0. Dividing each term by minus 1, we will be having x squared plus 4x plus 4 equal to 0, which again can be factorized. It's a perfect square. It's x plus 2o squared equal to 0, and we can solve for x to get x coming out as minus 2. And when x is minus 2, okay, when x is minus 2, y will be 6 of minus 2 plus 1, which is minus 12 plus 1. So y will be minus 11. All right. So therefore, the coordinates again we get here, the coordinates will be minus 2, the x coordinate, and minus 11 here. So minus 2 and minus 11 is what we get. So that's how we do it on this particular question here. So that does it. Let's go on to number 7. So on question number 7, it says the function f is defined by f of x is equal to 1 plus 3 over x minus 2 for values of x that are greater than 2. Right. So on part A, they say state the range of f. All right. So here we want to find the range of f, and first of all, if you look at the domain for the function is x is greater than 2. Now this is the same as from 2 to infinity. All right. So if we are going to get the range, we are going to get the corresponding values for f when x has a value of 2. Now for f of 2, we know that we are substituting 2 for x here, and it becomes 2 minus 2. So 3 over 2 minus 2, which is 0, will actually give us infinity. So f of 2 gives us infinity. We will also do f of the upper limit, which is infinity. All right, so if we substitute infinity for x here, okay, it will be as good as we are saying as x approaches infinity. That is, as x becomes very large, you know that this fraction, as the denominator becomes very large, this fraction will increasingly tend towards 0. So we know that 3 over x minus 2 will approach 0. So if this whole thing becomes a 0, then f of x will be 1 plus 0, which is 1. So therefore, f of infinity should actually give us 1. All right. So what we actually have is 1 to infinity. All right. And better written, this is f of x is greater than 1. So I'll take this to be the range of f right here. Okay, let's move on to part B. On part B, the question says, obtain an expression for f inverse of x and state the domain of f inverse. All right. Okay, so I'll have the function as y is equal to 1 plus 3 over x minus 2. All right, then I'll interchange the variables, which means we'll be having x is equal to 1 plus 3 over y minus 2. So I'm going to make y the subject right here. Okay, let's do that. So that's going to be x minus 1 is equal to 3 over y minus 2. All right, and we can multiply both sides by y minus 2 and divide both sides by x minus 1. So we'll be having y minus 2 being equal to 3 over x minus 1. All right, and we can take the minus 2 to the right so that we have y coming out as 3 over x minus 1 plus 2. So therefore, the inverse, f inverse of x, is that it is equal to 3 over x minus 1 plus 2. Now, they also say that we should state the domain of f inverse. Now, you need to know the fact that the domain of f inverse is comparable to the range of the original function. And we got the range to be f of x is greater than 0. Okay, that's the range of the original function, which means that the domain of f inverse should be that. So it'll, in this case, be that x is greater than 1. So this here is the right answer right here. That's how we answer part B. So I hope you got that. All right, let's go on to part C, shall we? Now, it says the function g is defined by g of x is equal to 2x minus 2 for x is greater than 0. So on part C, they say, obtain a simplified expression for g of f of x. Right, so let's answer this particular question here. They are saying we should find g of f of x, right? G of f of x, and this is as good as g of, and for f of x, we have that as being 1 plus 3 over x minus 2. So 1 plus 3 over x minus 2. That's what we have, all right? Now the function g has its inputs, like x coming out as 2x minus 2. So this should be as good as 2 of 1 plus 3 over x minus 2, okay, minus 2. All right, so multiplying 2 into the bracket, we get 2 plus 6 over x minus 2 minus 2, which then gives us the final result being 6 over x minus 2. So that is the simplified expression for g of f of x. So that's basically how we do it for this particular question. Now we want to move on to the next question. Let's do that, and that's question number 8. On number 8, it says the diagram shows part of the graph of y is equal to sine of a of x plus b, where a and b are positive constants. So on A, they say state the value of A and one possible value of B. All right. Now, we have this graph, and I want you to look at the function. It's y is equal to sine of A of x plus B. All right. Now, we can say that the graph has been derived from the original sine graph, which is y is equal to sine of x, right? And we can see here that the only transformations that are taking the graph of y is equal to sine x to y is equal to sine of a of x plus b are x transformations. All right, they are horizontal transformations. We have a stretch with the a and we have a translation with the b, and these are all x transformations. It's a stretch in the x-axis, parallel to the x-axis, and the translation parallel to the x-axis. So that's what we have right here. There is no vertical transformation going on. So if I am going to draw on the same sketch just a part of the graph of sine, which is the original graph, we know that it will be passing through the center, through the origin, I should say, and it intercepts the x-axis at pi, and it actually has a maximum value at pi over 2. We know that, right? It should be having a maximum value at pi over 2. This is just a small part of the graph of sine, and we are doing this just for us to understand what kind of transformation has happened, and that will actually help us determine what the value of a and the value of b is. All right, so we are first focusing on the horizontal transformations. Let's start with the fact that the graph of sine of a of x, ax plus b now has a big, is now wide, this wide, from its intercepts with the x-axis. Okay, it's now this wide, from minus a third pi to 5/3 pi, which is, it now has a width of 2 pi for that, for those intercepts. All right, when originally it only had a width on the intervals, on the intercepts with the x-axis, of a pi. So we're saying it's from a width of pi on sine x. Okay, let me just remove this. Okay, so pi, and now it has, actually it has widened to 2 pi. All right, so this is a stretch, okay, of times 2. How do we express it in the sine function? All right, that will mean that we actually will be saying for our a, which actually represents a stretch parallel to the x-axis, the value of a in the function should be a half. You know how with a stretch parallel to the x-axis, if your graph widens or stretches by 2, then on the function it's 1 over 2. Then we can also see that originally, if we take a point on the original sine graph, which is at 0, you can also see that on the transformed graph of sine of ax plus b, a of x plus b, that same point seems to have moved to the left by minus a third units. All right, but inside the function, if it's in the negative, then we have to use a plus. So that actually means that for us, b is equal to positive of a third pi. So these things actually work in opposites. If it's a stretch and it's a stretch by 2 times, then in the function it will be 1 over that number of times. If it's a translation, if it's going to the left, then we use a positive value inside the function. So it was minus a third, but now it becomes positive of a third. So our answers right here are a is a half and b is a third pi. So that's how we do it for this particular question, part A. Let's go on to part B. On part B, the question says another curve with equation y is equal to f of x has a single stationary point at the point PQ, where P and Q are constants. This curve is transformed to a curve with equation y is equal to minus 3 of f of a quarter of x plus 8. So on part B, they say, for the transformed curve, find the coordinates of the stationary point, giving your answer in terms of P and Q. All right. So basically, we are transforming the point PQ through this transformation. Now, it's important that you understand which transformation affects which coordinate. All right. Now, the minus 3 is a stretch parallel to the y-axis. All right. And it is going to affect the y coordinate. So the new y coordinate, let me use black. The new y coordinate is such that it's actually minus 3 times the y coordinate, so it's minus 3 times q, so it's minus 3q. All right. Next up, let's talk about the x coordinate. Okay, for the x coordinate, what's affecting the x coordinates are the stuff we have inside the bracket under f. Okay, so a quarter is a stretch. It's a stretch where actually the it's a stretch by factor of a quarter, but the x coordinate will be transformed in such a way. Remember, we use a reciprocal for the stretch in the x-axis. So if it's a quarter, then it means the p is being multiplied by 4. So it will just be 4p. Not only that, you can see that again we have a plus 8. Since it's a plus 8, it means the translation is in the negative. So it's minus 8 on the x coordinate, so minus 8 like this. So the coordinates will be written 4p minus 8 and minus 3q right here. So that's basically how we do it for part B. Okay, so that's how it is. Let's go on to the next question, which is number 9. It says a curve has equation y is equal to 2x to the half minus 1. So in part A, find the equation of the normal to the curve at the point A with coordinates 4, 3, giving your answer in the form y is equal to mx plus c. Right. So key part is that we want the equation of the normal. So to get the equation of the normal, we need the gradient of the normal. We have a point on the normal already, so the only missing thing is the gradient. So let's start by finding dy by dx here. Differentiating this, we get half. Actually, there's a 2 already, so we're going to say here 2 of a half of x to the power of a half minus 1. So this actually, differentiating minus 1 is 0, obviously. So this will give us x to the power of minus a half. All right. Now, when x is equal to 4, remember the point A has coordinate of 4. dy by dx will be equal to 4 to the power minus a half, which is actually a half in itself, so a half. So therefore the gradient of the normal, remember the normal is perpendicular to the tangent. It is the tangent at A that has a gradient of a half. So the gradient of the normal should be minus 1 over a half, which actually is minus 2. So we now have the gradient of the normal. So now we can find the equation of the normal. So for the equation of the normal, we will say y minus 3 is equal to minus 2 of x minus 4. I'm using the 0.43 and minus 2 for the gradient. So it'll be y is equal to minus 2x plus 8 plus 3, which is the minus 3 gone to the right. So the final answer will be y is equal to minus 2x plus 11. So that's basically what we get for this particular question right here. All right, let's move on to part B. On part B, it says a point is moving along the curve y is equal to 2x to the half minus 1 in such a way that at A, the rate of increase of the x coordinate is 3 centimeters per second. So on B, find the rate of increase of the y coordinate at A. Right. Okay, so from the information given, we have been told that the rate of increase of the x coordinate is 3. That's like dx by dt is equal to 3. Then we know that dy by dx, we got that to be x to the power minus over half. And they say it's at A. So let me just say at A, dy by dx will be what? I think we'd already determined that at A, dy by dx is actually a half. All right, so it's a half. Okay, so they want us to find the rate of increase of the y coordinate. In other words, they want us to find dy by dt using the chain rule. That will be dy by dx times dx by dt. So basically dy by dt will be equal to dy by dx is a half, and it's times dx by dt, which is 3. So the answer should be 3 over 2 or 1.5. Okay, and that'll be centimeters per second. So that's the answer we get to part B. Let's go on to the next part, which says at A, the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of the y coordinate is constant at 5 centimeters per second. So it says as the point moves down the normal, find the rate of change of its x coordinate. All right, so in this particular case, we have been told that the rate of decrease of the y coordinate is 5 centimeters per second. So that's like dy by dt is equal to minus 5. All right, and here we're talking about, they're actually saying that the point or the moving point is now moving down the normal, and we know that the dy by dx for the normal, all right, the gradient of the normal, we had gotten that at A to be minus 2. So basically that has to be minus 2. And now they want us to find the rate of change of the x coordinate. All right, so that's dx by dt, which by the chain rule should be dx by dy by dy by dt. That's how we can have the correct chain rule. So basically this will be dx by dt equals to, and for dx by dy, that's going to be 1 over minus 2. And it's going to be times. Now for dy by dt, that's minus 5. So essentially, we will be having this as 5 over 2. And the units here are in centimeters per second. So that's the answer we get right here. That's how we do it. All right. So let's move on to the next question. So we're now on number 10. It says, the diagram shows the points A, B, and C lying on a circle with center O and radius R. Angle AOB is 2.8 radians. The shaded region is bounded by 2 arcs. The upper arc is part of the circle with center O and radius R, and the lower arc is part of a circle with center C and radius capital R. So on part A, they say, state the size of the angle ACO in radians. Okay, so we want to answer that first question right here. Okay, so we are talking about the angle ACO right here. Okay, if we use a bit of psychogeometry, we know that the angle at center is twice the angle at circumference. All right, so we know that if we have a 2.8 radians angle here, then this angle here, which is the angle at the circumference, should be half of 2.8, and that means that it should be 1.4 radians, which should also mean that the angle, this angle here, should be half of 1.4, so this should be a 0.7, and we know that this angle here is again 0.7. So to get the angle, actually ACO, we've actually found it already. So we are saying here that ACO is 0.7. So here, no need to put the work in. You don't get any marks for, because they are saying stat the size. So we have just done that. It's 0.7, and the logic is I have used psychogeometry to know that the angle at the center subtended by an arc at the center is twice the angle at the circumference. So 2.8, so this should be half of that, 1.4, and the angle ACB is split into 2 equal parts. So ACO is the other half, and it's half of 1.4, so it's 0.7. So that's how we do it for part A. Let's go on to part B, which says find capital R in terms of small r. Okay, right, so let's consider this triangle here for that. So we want to consider this triangle here. Okay, so if you look at this triangle that I've just drawn, you can see that we can actually draw a perpendicular. It's an isosceles triangle. You know how we have R here and R here according to what they've given us. So it's an isosceles triangle, and this is equal to this. All right, so we can say, if we just decide to use one of the right angle triangles like this one here, we can actually say that this is half R, and cos of 0.7, let me write that down. So I'll say here cos of 0.7 is actually equal to the adjacent side, which is half R, over hypotenuse. So it's half of R and it's over R. Okay, small r. So here it is going to be, to get the capital R, it will be 2R cos of 0.7. Now we can calculate 2 cos 0.7, and we have to be in radians mode. So I'll take my calculator to radians mode. Okay, let me just do that. All right, so that's 2 of cos of 0.7, and we get 1.53 to 3SF. So basically R is 1.53 of r. So that's how we can express R in terms of small r, right? Let's go on to the next part, which is part C, where they say we should find the area of the shaded region in terms of R. Okay, so let's have the diagram, which is right here. So that's the original diagram we have, and they want us to find the area of the shaded region. All right, so to get this area, I am going to use the segments method. So I'll draw a line right here, like this one here, and I am going to say for the shaded region, okay, so shaded region, it is going to be equal to the segment area here. All right, and we are going to subtract from it the segment area of the other second segment of the other circle. All right, so basically I'm gonna put it as, it is gonna be area of the bigger segment minus area of the smaller segment. Okay, so for the bigger segment, we are talking about this segment here, and the center is actually the center, or that's the center of the circle to which this segment belongs. All right, so the angle is 2.8 radians right here, and we're going to use the formula half r squared of theta minus sine theta, and this is the formula for area of a segment. So this works every time when we're calculating area of a segment. So convenient it is. All right, so we are saying right here for the area of the bigger segment, that's half of small r, so r squared of theta, which is 2.8, minus sine of 2.8, and that's going to be minus. Now we're considering the smaller segment. Now the smaller segment is, let me just draw that line. The smaller segment is this segment here, and the center is C. Okay, and the angle here is half of 2.8, so it's 1.4. So to get the area of the segment, we'll use the same formula. Here the radius is capital R, so it's half r squared of theta, which is 1.4, minus sine of 1.4. So this is what we are working with. All right, so this is as good as half r squared of 2.8 minus sine of 2.8 minus half. Now for capital R, we had gotten that capital R is 1.53 of small r, so I'll say 1.53 of small r squared of 1.4 minus sine of 1.4. All right, so let's do the calculation. Let's start with this first part here, and here we get 1.2325, so 1.2325 of r squared, and that's going to be minus, calculating the other part. Let me do that quickly, and we get 0.4852 2, so 0.4852 r squared. So we're gonna subtract the 2 and we get to 3SF 0.747, so 0.747 r squared. So this here is the area of the shaded region, and that's how we do it right here. We need to move on to the very last question, which is number 11. It says the diagram shows part of the curve with the equation y is equal to x plus 2 over 2x minus 1 squared. The lines x equal to 1 and x equal to 2 intersect the curve at P and Q respectively, and R is the stationary point on the curve. So on part A, verify that the x-coordinate of R is 3 over 2 and find the y-coordinate of R. Okay, so here they say we should verify that the x-coordinate of R, and R is that stationary point, and that is 3 over 2. So let's do that. Right, so to get the x-coordinate of the stationary point, we are going to do dy by dx. So we're differentiating this function. So differentiating x, we get 1. Differentiating this, all right, will give us, we know that this is the same as x plus 2 of 2x minus 1 to the minus 2. So that will be 2 of minus 2 of 2 of 2x minus 1 to the minus 2 minus 1, which is minus 3. So basically this is 1, and that's minus 8 over, then this is going to be 2x minus 1 to the power 3. So that's what we are having right here for dy by dx. So now we know that at the stationary point, dy by dx is equal to 0. So basically we'll be having 8 over 2x minus 1 to the power 3 being equal to 1. So 2x minus 1 to the power of 3 is equal to 8. Then if we cube root both sides, we'll be having 2x minus 1 is equal to the cube root of 8, which is 2. And if we take minus 1 to the right, it adds to 2 and they become 3. So 2x is equal to 3 and x is 3 over 2. So that's how we show or verify that the x-coordinate of R is 3 over 2. So that's how we do it right here. But they also say that we should find the y-coordinate of R. All right. So for the y-coordinate of R, we are going to say that if x is 3 over 2, when x is equal to 3 over 2, y will be equal to 3 over 2 plus 2 over 2 of 3 over 2 minus 1 all squared. So we can actually simplify this, which will be 3 over 2 plus, this is 2 over, and 2 times 3 over 2 is 3. 3 minus 1 is 2. 2 squared is 4. So we have a 4 here. So basically a half. So 3 over 2 plus a half is 4 over 2. So we get y being equal to a 2. So y is 2. So that's the y coordinate. So we got the x coordinate. We verified that it was 3 over 2. And the y coordinate here is indeed 2. Is 2. Alright, let's go on to the next part, which is part B, which says find the exact value of the area of the shaded region. Alright, so let's take the diagram, the original graph right here. Okay, and if you look at the diagram here, to find the shaded region, we first need to find the area, this area here, which actually is a trapezium. And then we'll subtract from the area of the trapezium, we will subtract the area under the curve. All right, so that's what we're going to be doing here. So to find the area of the trapezium, we need to find the coordinates of P and Q. So that's the first task. That's the first thing we need to do. Right, so to find P, we know that we can find P using the fact that actually we have the x coordinates of P and Q already, but I mean we need to find the y coordinates. Alright, so to find the y coordinate of P, we know that x is 1. Alright, so using the equation of the curve, which I'm placing here, we are saying when x equals to 1, y will be equal to 1 plus 2 over 2 of 1 squared, which is 1 plus 2 over 1 squared. So it's basically 1 plus 2, so y should be at 3. Alright, and when x equals to 2, that should be the other point. Here x is 2, so when x is 2, this will be 2 plus 2 over 2 of 2 minus 1. Now 2 of 2 minus 1 is 3, so it's basically going to be 3 squared, that's a 9 here, so it's 2 plus 2 over 9, which is 20 over 9. So that's the value of y when x is 2. Y will be 20 over 9. So essentially we have 3 and 20 over 9. Okay, 3 here and 20 over 9 here. So we can now actually find the area of the trapezium. Okay, so I'm saying here the shaded area is equal to area of trapezium minus the area under the curve. The area of the trapezium is half of the sum of parallel sides. The parallel sides are the P and Q, that's 3 and 20 over 9. So basically we have 3 plus 20 over 9 times the perpendicular height. The distance between the parallel lines is a 1. So that's just plot times 1. It's minus. For the area under the curve, we'll find that by integration. And we're integrating the area under the curve between the limits 1 and 2, basically. So 1 up to 2. And we put in the equation of the curve. Okay, actually we just put this part is what we want. So we are integrating this thing here, and it's with respect to x. All right, so this here is half, and 3 plus 20 over 9 should be something like 47 over 9, and that's going to be minus. Here we are going to be integrating from 1 up to 2, x plus 2 of 2x minus 1 to the minus 2 with respect to x. So here we have 47 over 18 minus, and we're now integrating x, we get x squared over 2, and integrating this other part is 2 of 2x minus 1 to the minus 2 plus 1, which is minus 1 over 2 of minus 1. All right, and the limits are 1 to 2. So we have 47 over 18 minus, and this here is x squared over 2, and this becomes minus 1 over 2x minus 1 when simplified, and it's 1 up to 2. All right, so basically this is what we have, and this is going to be 47 over 18 minus, now we're substituting 2, so 2 squared over 2 is 2 minus, substituting 2 here is 1 over 4 minus 1, so it's minus a third, right? And it's going to be minus, now substituting 1, so 1 squared over 2, which is a half, and minus this is going to be a plus 1 over 2 of 1 minus 1, which essentially is 1. All right, so this is what we have. So this is going to be 47 over 18 minus, here 2 plus 1 is 3, and 3 minus a third minus a half should give us minus 13 over 6. So we're going to say here 47 over 18 minus 13 over 6, and this gives us 4 over 9, and this actually happens to be the area. This here is the area, the shaded area as required, and that's basically how we do it. And that actually does it for this paper here.